So welcome back. This is the second example of our first experiment. In this example, the problem is if the three sides of a triangle are entered through the keyboard, write a program to check A, whether the triangle is valid or not, and B, check whether the triangle is isosceles, equilateral, scalene, or if it is right angled. So let's get to the code. So here, at first, we are declaring the libraries, the headers, then our main function. In the main function, we are declaring three variables, and the type of these variables are integer type. These three variables will save the lengths of three sides of a triangle. So we are taking the lengths of three sides from the user using scanf commands. Printf enter the length of the first side, and notice for the user, it is instructing the user to give the length of the first side as input, and the input from the user is then saved in the variable A. In the same fashion, the second and the third side lengths are also taken from the user and they are saved in B and C respectively. So we are done with the variables. Now the first thing we have to check is whether the triangle is valid or not. So what is the condition of a triangle being valid? The condition is if the length of the two sides are added, the sum must be greater than the length of the third side, and it is true for every pair of the sides. That means if we add A and B, it must be greater than C. If we add B and C, that must be greater than A, and if we add C and A, that must be greater than B. So all of these conditions must be met. If two of these conditions are met and the third one is not met, even in that case the triangle is not valid. So if these three conditions, A plus B greater than C, B plus C greater than A, C plus A greater than B, if all these conditions are met, you can see we are putting AND here, not OR, we are putting AND. So if all these three conditions are met, then we can decide the triangle is valid. And if the triangle is valid, in that case we will check for further steps, equilateral or scalene or whatever. But if it is not, else we will just print that this triangle is not valid or just not valid. Now if the triangle is valid, in the second step we have to check whether it is equilateral, isosceles, or scalene. So how can a triangle be scalene and how can it be equilateral or isosceles? The conditions are as follows. Let me demonstrate it with some numbers. A triangle is called equilateral triangle if all three sides are equal. So if you take A, B and C, it will be equilateral if A equal to B equal to C. How it can be isosceles? It can be isosceles if two of its sides are equal and the third side is not equal. And it can be in any combination. A equal to B not equal to C, or B equal to C not equal to A, or C equal to A not equal to B. If any of these conditions are met, you can say that it is isosceles, and if this is true, then it is equilateral. And if three lengths are just different, we will call it scalene. Okay, so this is the demonstration. Now let's go back to the code and let's see how we are doing it. So at first we are checking that if two of its sides are equal, A equal B, or B equal C, or C equal A. We are just checking that whether two sides are equal, at least two sides are equal. So OR means if we want to execute this block inside if, then at least any one of these conditions must be true. Previously it was AND. In that case all of these conditions needed to be true. But if we are using OR, then any of these conditions being true will do the job. We don't need all the conditions to be true. Only one can be true, only two can be true, and even three can be true. So at first we have to check whether at least one set of side lengths are equal. It can be A and B being equal, it can be B and C being equal, or it can be C and A being equal, or multiple combinations may be true. A may be equal to B and B may be equal to C. So we have to check if at least two sides are equal. So if two sides are equal, then there is a chance that it can be either equilateral or isosceles, because for the equilateral all three sides are equal. For isosceles, two sides are equal. So if we find that at least two sides are equal, then there is a possibility that it can be isosceles or equilateral. But if we find that at least two sides of a triangle are equal, then it can never be scalene. It can never be, because for a triangle to be scalene, all three sides must have different lengths. So if one of these combinations are met, then we can say that if it is either equilateral or isosceles. Else, if none of these conditions are met, then we can surely say that it is a scalene triangle. See, else it is scalene triangle. Now if one of these conditions are met, we have to check that if all three sides are equal. If all three sides are equal, we are doing it in this block. You can see if A is equal B, or it means A is simply equal to B and B is equal to C. You can see we are using AND here. A needs to be equal to B and B needs to be equal to C. If A and B are equal and B and C are equal, A and C are by default equal. So that condition is not put here. Only two set of conditions are put here. A is equal B and B is equal C. So if these conditions are true, if these conditions are true, both of them need to be true. There is an AND in between, so both of them need to be true. If both of them are true, then we can say that it is an equilateral triangle. It's an equilateral triangle because all three sides are equal. A is equal B and B is equal C. That means all three sides are equal. That means it is equilateral. Otherwise, you can see there were three conditions here. So if at least one was met, we will go into this if block. So in some cases you will see that all three conditions will be met. All three conditions will be met. That means this will pass through this if block too, and it will be equilateral. And if only one of these conditions are met, if it is only A equal B, or only B equal C, or only C equal A, then it will pass this if block. But in this if block there are another if block, but it will not pass this if block because A may be equal B or B may be equal C, but both of them are not true. So in that case it will be an isosceles triangle. So now we are done checking if it is equilateral, isosceles or scalene. Now we have to check if it is right angled. Checking right angle is very straightforward. At first we have to square every side length. So we are declaring three variables, A SQ, B SQ and C SQ. This SQ means obviously squared. So we will just raise the power of these three variables to 2 using pow function. We are including the math library here. You can see math.h. So in that library we are having this pow function. So pow a comma 2, pow b comma 2 and pow c comma 2. So now a squared, b squared and c squared are available. Now we have to check if the Pythagorean theorem is applicable to this triangle. Pythagorean theorem means the square of the two sides, if we add them, it will be equal to the square of the third side. So we have to check if it is true for at least, or if it is true for only one combination. So we are putting a square equal to b square plus c square, or b square equal to c square plus a square, or c square equal to a square plus b square. One thing to note, these three conditions cannot be true simultaneously. One case is all of these three conditions are false. All of them are false. In that case, this if will not be executed. But if at least one of these combinations are true, if at least, or in this case there will be only one combination being true. It can never be, it is not possible that two of these combinations are true. It's not possible, because we know that only the length of the base and the length of the height being squared and then summed, it will be equal to the square of the hypotenuse. If you square the hypotenuse and add it with the square of the base, it will not be equal to the square of the height. So it will be always true in only one of these cases. So we have to put all three conditions, because we don't know which condition which condition it will be true. Sometimes this may be true, sometimes in some other cases this may be true, in some other cases this may be true. We don't know which combination will be true, but we know that certainly all these three conditions will not be true simultaneously. Only one of them will be true at once if it is right angled. So if it is not right angled, then all three will be false and it will not be executed. If it is right angled, then only one of these combinations will be true, and that will be enough because we have OR in between. Let's say this one is true, then it is 1, true means 1, 1 or 0, false means 0, 1 or 0 or 0. We know that the rule of OR, 1 or 0 means 1 obviously, and this will be executed and it will be printed that this triangle is right angled triangle. Now let's take this. We are building and running the code. Okay, so let's do something about some invalid triangle. Let's say the first side is 7, second side is 5, third side is, let's say, 100. It is obviously invalid because 7 and 5, if we add them, it is just 12. So it must show that it is invalid. Yes, so it's not valid. So again, run again. Now we can just run, we don't need to build it again. Now let's do something for, let's say, scaling triangle. Let's say 5, 12 and 13. You can see it is scaling because these three are different, and also it is right angled because 5 square plus 12 square is 13 square. So it is both scaling and right angled, so it is rightly given in the code as output. Okay, so let's move on to the next. Now let's check for equilateral triangle. Let's say all these combinations are equal, 5, 5, 5. We can see it's equilateral, so it's done. Now let's move on to isosceles. 6, 7, 7. You can see it's isosceles. So that's all for this code. We will come back with another code in our next video. Thank you.